Ah, hey guys, I stuffed up this program a whole bunch of times trying to record myself making it, and then I spent a whole bunch of time going back through the code, looking for errors. And I figured rather than do that, I'm just going to go through one that works, and we can go through it together. So, and I'll write some comments in so it makes sense. Because yeah, not going to lie, I've been sitting here for a long time. Okay, so inside our main program, what we're going to first do is we're going to initialize the array based off the entered size. Right? So you'll say put in whatever size, whatever they enter will then be stored as a variable called array size. Then what we're going to do is we're going to create an array called a to the specified size. All right. Cool. All right. Cool. 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 All right. Let's do that. Awesome. Okay. So this loop here, all this is essentially doing is it's same as the last one. It's going through and asking for the value to be entered. Because arrays are initialized with the value 0 in those empty spots, it does say that if the value is already 0, then forget about the loop and sort of just carry on. But yeah, for the most part, that should be pretty straightforward, this for loop. So this is going to get the user enter each value. All right, get the user enter each value. That's going to be that for loop. It's going to iterate through a whole bunch of times. Then here we're going to run the quicksort function, which is written below. Right? There's a function, and there's a couple of values in here. So you might notice A is the array, 0 is the number 0, and then the array size minus 1 is how many values are in the array, or it should say what value is the final spot in the array. No, that's not right. That's not even the right way to put it. It's what number can be used as a reference to find the value in the last spot. So if there's 6 values, this is spot number 5 because these 6 values will be in array spot number 5. Right. So that's going to run that quicksort, and then this is just going to print out our ordered list. List, and then just wait for OK press. All right. Yeah. So it's just like a read line. Yeah, I wouldn't worry about that too much. Okay. So it should be pretty straightforward. It should just iterate through every single item on the list. Now we've got a function here and also a sub here. So subroutine and a function. We're going to go through those two things now. So it might make most sense to go through the subroutine first, and then we'll come back to what partition does because it's probably the hardest bit. So what the quicksort subroutine does, it's very quick. What it does is it brings in a couple of values here, and they don't need to be there. Get rid of those. They don't need to be there anymore. All right, old school coding. Okay, so yeah, they don't need to be there. So basically, it brings in when this says by ref, it means refer to the location where A is being stored. So it's better for arrays, for example, because it's not returning a singular value, whereas these two are both values, right? It just makes things run a bit smoother. So we've got the letter L and the letter R, which we'll be referring to. If you look originally, we have 0 and array size minus 1. So essentially this L is the the zero, the first sort of spot of the array, where it begins, and this R is going to be where it ends, right? And then it says if R is bigger than L, right? So while the end of the array, right? So this could be rewritten as end and begin, if that makes a bit more sense, right? I'll then have to muck around and change these. But it might be a bit more user friendly, right? No, but I shouldn't use end. I'll use last. This might make it a little bit more user friendly. Stupid letters. Okay, so this is the beginning, the first value of the array, and then the other one is the final value in the array. And essentially what it's saying is if at any stage this final value is somehow bigger than the value we're beginning with, that means that we're sorting sort of sorting values that are not there, right? We're trying to sort a list that doesn't exist, right? This M, midpoint is probably a better thing to call it than just M. I'm going to just change this to mid. And what this is going to do, essentially we're going to partition the list, this array into a beginning and an end, right? And essentially that's going to find our middle value and sort of split things, sort of find that essentially that central value, and then we can run this list sort again using that middle value as like a to determine where the start and the end of the list is. I know that sounds a little bit confusing, so I apologize for that. But essentially, think of if we have an array of say 7 values. Essentially, what we're going to do is when we run this partition, it's going to send back that we have to go one below the middle value, right? And that's going to give us our first list. So from the beginning to one below the middle value, one above the middle value to the end will give us our second list. We're sort of splitting them in two. And this is actually a self-referential, and I'm not going to bore you to death with this because you don't need to know. But essentially this refers to itself as a subroutine. So it's like recursion if you do that in mathematics. But anyway, so essentially here we're saying that if the end of the sortable values is lower than the beginning, you have no list, right? If it's equal to, it means there's only one value in the list, but if it's greater than, it means you have no values in the list, right? So yeah, we're gonna split the list and determine midpoint. Then we're going to sort the bottom half. Then we're going to sort the top half. All right. That's what we're doing. I've got this weird feeling that I'm not recording. Okay. That's what I got. Now the last thing that we need to go through is just the partition, which is an important bit because it splits up the list into workable sections. Right. So again, I apologize about the variable names. I know that's a bit annoying. Similarly to before, the L is just referring to the beginning, the R is referring to the end, right? And because I don't want to muck around with these values, I want to save them and use them later on. I've actually set up two variables here. One of them is essentially the new beginning, right, which is just denoted as the letter J, right? So I can change this to begin in here, right? Right, I'm just called beg for short. And the P is our pivot value, right? Which we can call piv. It makes it easier. Actually, you know what? Rather than do that, change everything and say no. J is our beginning value. P is our pivot value. So remember when we were doing that list, we were doing sorting of the list. This sort of goes back to the last one that I was drawing. We had our list of numbers here. Something like that. And the pivot value is either the middle one, it could be the last one, it's whatever you choose it to be essentially. So that'll work either way, so don't stress too much. And essentially you're checking everything up against this pivot value and seeing if it's higher or lower. And if it's lower, it's going below, if it's higher, it's going above. That's essentially what we're doing here. Alright. So this just loops through the list. Okay. So we're looping through the list, and then this says if a value is below the pivot value, then we swap some things. So we swap some values. Alright? So only in that circumstance. Okay. So we temporarily store the value. The AI is referring to the current spot in the array of the current comparative value. That's probably a good way to put it. You get the idea, right? So whatever we are currently up to in the array gets stored in this temporary variable, right? And then it says AI equals to AJ. So remember, J is our beginning value, right? So we're temporarily storing our beginning value. We're temporarily storing our current value in a variable called TMP. Then after that, whatever was our current value is then getting overwritten by whatever our beginning value was, right? So remember, J is our beginning value. So we're going to overwrite the current value with our beginning value. Right? Now overwrite that. And then we swap the current value in as the beginning value. Right? So essentially that's going to sort it below the pivot is what I'm saying there. Right? So we're sorting it below that pivot. And that means that it's going to be on the right side. So, for example, let's say our current value is 1. We're comparing that with 7. Okay, 1's lower than 7, so our value that's we're going to push this to the start of the array somewhere. We're going to put it over here because it's lower than 7. All right, that's the idea. And then we're saying we're going to swap 7 in to where 1 was. Yeah, so this remains to be the sorted half of the array, and that remains to be the unsorted half. Yeah. Anyway, let's move on from there. And then of course we're going to increase the sloppy way of doing it. That's the Python way of doing it. Forget all the Python garbage as I tend to write. Right. So then we're just going to add onto the beginning value. And the reason that we do that, the reason that we add on to that is we don't want to look at, say, this spot anymore, because that's already locked in. Yeah, so we don't want to deal with that anymore. So we're moving our beginning value to 2 this time, and we're comparing it with the pivot. Yeah, we don't want to deal with that. Add to the beginning to leave some values in a sorted partition. So we'll have the sorted part and then the unsorted part. Alright? Okay. So that's going to iterate through, and it's going to do that for all those values there. So there's a few things we have to write down here. And then finally, there's a couple of things that we're going to do here. So a couple of swaps around. So we've got array the array value R. And remember, if we go back to the start, the R is our ending value. Yeah. So array value R was our ending value, right? So our ending value is now going to equal our beginning value. So our, how can I put this? Our sorted portion. No, that's not the way to put it. This is the way to put it. We are changing the beginning value to be the midpoint pivot, midpoint slash pivot value, right? And then our beginning is now whatever the point, the reference of the pivot was. I'm sorry if that's a little bit confusing. I'm sort of struggling to articulate that. But you sort of get the idea, at least for the most part. So essentially, we're getting them to enter in their values. It skips through. It gets you to enter all the values, and then it sorts them into these quick sorts. The quick sort partitions it so there's a bottom half and a top half, and then we run this quick sort for the bottom half. This runs this program again. Then for that bottom half, it partitions again, and it keeps partitioning until essentially it's done. All right. And it does that for the top half too, which is how it sort of works, if you remember. Now, hopefully I didn't stuff this up by changing the variable names around. That would be kind of embarrassing, particularly after I was talking about how this works. But let's enter an array value of 10. I'm just going to enter some random digits here. Some sort of order. And you can see that it has partitioned and sorted them out as it goes. I'm going to make this program available to you. I had a bit of a tough time writing it myself, to be honest. This is partially someone else's subroutine, at least, and partition function. I'm going to make this available to you. What would I encourage you to do? Have a read through it. If you're interested, each time the partitions, try running a little sort of loop that prints out the array and see exactly what partitions you're looking at. Could be kind of interesting. All right. I'm going to stop the video here. Have a good one.